So a few things. There's not really much extra I need to tell you about the S. You simplify by factoring and canceling out anything that's exactly the same on the top or bottom. And one thing I want to take this moment to say is every problem is different. So if you kind of love to be told one method of doing something and then knocking it out 20 times in a row, just turning your brain off and doing it really, really fast and just getting it done, this is not the material for that, okay? Each problem looks a little bit different and has different stuff going on. So for example, when you're simplifying, maybe in one problem, you didn't have to cancel out anything. Or maybe you didn't have to factor anything. Maybe on the next problem, you only have to factor the denominator. And maybe the next problem, you have to factor both, and there's stuff that's squared here and stuff that's not squared there. So every single problem is different. This step right here, the H step, is only for if you canceled something in the S step. Okay? So this comes about only if you canceled out factors from here. The roots, okay, the R for roots. Remember that roots are the x-intercepts, okay, the solutions. It's where your graph crosses the x-axis. You get that by setting the numerator equal to 0 and solving. The numerator, that's been factored. Okay, so when you do the root step, you're using factored form. And you're just setting the top equal to 0. And because they're roots, you will write your answer in this form as a point. Right? And then you'll graph your point. So when I say set the top equal to 0, I mean from the factored form. Same thing with A. Okay, so R is letting the top equal to 0. A is letting the bottom equal to 0, the denominator. This, when it says set the bottom equal to 0, that means from the factored form. And while A does stand for asymptote, specifically in this step, it's the vertical asymptote only. The horizontal one comes later in the acronym. So these are vertical asymptotes. You set the denominator equal to 0. You write your answer as a line. Okay, x equals some number. And it's a boundary line that the graph can never cross. It's not actually part of the graph. That's why we put the dots there. It's more like a placeholder. It determines the behavior of the graph, but it's not actually part of the graph. Does anybody need that up anymore? Any of that? Okay. The T part is kind of the most troublesome part. See how I did there? See the word troublesome? T? Thank you. T is for tangent or together. And please remember, it's written as a fraction on purpose. Tangent over together. The tangent is from the numerator. That's your root information. And together is from the denominator. That is your asymptote information. Okay, is it tangent at the root? Is it together at the asymptote? And it says here, these give clues about special behaviors of the graph. What you're looking for is you're looking at factored form. Okay, the S step. In the top, in the numerator, if any of the factors are squared, squared means bounce at the root. Squared means a bounce. Okay. What does not squared mean? If it doesn't bounce, it does what? It crosses, right? So the question you're asking yourself when you're using that top information, is it going to bounce or cross at the root? And now that's not new information. We did that last semester. For the bottom, if it's squared on the bottom, if you have a factor squared, it means it's going to come together at the asymptote. It means that, because there's two pieces of the graph on either side of the asymptote, coming together looks like this. It's going in the same direction. It's either coming together and going down, or it's coming together and going up. And that occurs if it's squared, if you have a squared factor. If it's not coming together, it's going opposite. So this right here where it says together at the asymptotes, it says Special squared term on bottom means the graph will come together at that asymptote. And then even for even more reference, there's some examples of when terms are squared. So in x squared, this is a squared term, this is a squared factor. But this right here, for example, is not considered a squared factor because it's got that plus 2x attached to it. So remember, factors are something times something else. These are all factors. These are not examples of factors because they have the plus or the minuses connecting them without being in a parenthesis, without being in a group. The E is for end behavior. This is your horizontal asymptote. And on this one, you're looking at the original function, okay, not factored form. So look at original function. And in our class for regular college algebra, we will not be doing top-heavy asymptotes. Okay, those are actually oblique asymptotes. They're at angles. We're doing only horizontal ones in these cases right here. Please keep in mind that this is end behavior only. End behavior is how is the graph behaving as it goes to negative infinity and as it goes to positive infinity. It doesn't determine how the graph is behaving in the center. All right, so it's okay to cross the horizontal asymptote in the center of the graph. And there's a few things going on here. There's two different kinds of equations we can have. We can have a balanced equation, which means the degrees are equal on the top and bottom. So an example of that, maybe you have something like this, okay? So we have this function, it's rational, there's x's on the bottom. This would be my original before I factored. I'm looking at the leading terms for this piece. The leading terms are, when it's written in standard form, what are the first terms? The first term in the numerator here is 3x cubed. And the first term here is x cubed. We'd write that as a ratio, okay? And then we would simplify, and that would give me 3. I would use that right here in this form. It says write as a line y equals a number. The number is what you get here when you simplify. So you'd say, oh, okay, my horizontal asymptote is y equals 3. And then it says here, graph this line or at least its ends. Okay, at least its ends. Now, this is for when the degrees are equal. That's balanced. Bottom heavy is a different situation when the degree on the bottom is bigger. So instead of 3x cubed plus 4x squared, you might have 3x, just 3x plus 4 maybe, and then you might have anything bigger on the bottom like this. Okay? So degree on the bottom is bigger. You don't have to do any math for the horizontal asymptote. It's automatically going to be y equals 0 by default. Okay? So for bottom heavy, horizontal asymptote is y equals 0. But for a balanced function, you'd have to do that little bit of extra math right there. Does anybody need that up anymore, any of that stuff? Okay. And so then this last thing is the very easiest one to understand or remember. It's the y-intercept. It's where does the graph cross the y-axis? You're just going to plug in 0 for x. You can plug this into the original or factored form, whichever you like. You'll get the same output. Okay. And you write this as a point. It's 0 and then whatever your number is. So having sort of broken some of that down for you, I'm going to go back over yesterday's problem. And I want you to put your pencils down. And I just want your eyes and ears. I just want you listening and absorbing the information one more time. So we have this. The very first step, S, is blah, blah, blah. S means to simplify, so we have to factor first. So the top is a GCF problem. The bottom was a swing. Multiplies to -3 and adds to -2. And so I look at it and I say, okay, does anything cancel? It doesn't. There's nothing the same on top and bottom. So this step is not applicable. And then when I go on to R, this is where the top equals 0, because R stands for roots. So I take those two factors in the top, set them equal to 0, and solve. And then if I was using my cheat sheet and I was going back to double check what form does my answer have to be in, because these are roots, I know it's points. So I write the points. This 0 gives me a point, and this 3 gives me a point. X is -3. And then I put those on my graph. Okay, that's my roots. So that step was let the top equal to 0. The next step is let the bottom equal to 0, or the denominator. I have two factors there. I solve them. And when I'm trying to figure out what form to write, I know I can leave it like this because they're asymptotes. That means it's a line. And this is how you write a line. So I go draw those in with dotted lines because they're not actually part of the graph. They're just placeholders telling me the graph will never cross there. Okay. So that breaks my graph up into 3 separate sections that I'm going to have to deal with later. T is for tangent or together. So I have to look at every single factor individually. It just so happens that all the factors in this problem are the same in that none of them are squared. If one of them happened to have been squared, that means there's different behavior here than there is here. It would bounce here and cross there, and that would be okay. We would deal with that. But in this problem, we don't have it. So I can just say that no, nothing is tangent, so that means it's going to cross at the roots. And on the bottom, it's no, that means it's going to be opposite at the asymptotes. Okay, because that's root information on top, asymptote information on the bottom. E is in behavior. You go back to your original equation. You look at the leading terms there. Okay, they're both x squareds. You write it as a ratio. You simplify, and you get 1. And this is your horizontal asymptote. That is the equation of a line. So you would write it like this, y equals 1. And then draw it in. And like your SHRATEY sheet says, you can draw in just the ends if you want, at least. But I put it all the way across just as a visual reminder that it's there. And then y is where you let x equal 0. You plug it in to either the factored form or the original, whichever you like. If you did it in factored form, it would look like this. I plug 0 in for the x's. I get 0 over 0. It's just 0. Actually, I get not 0 over 0 because you can't divide by 0. Over -3 times 1 over -3 is just 0. Please notice I should have already known I was going to get 0, 0 because we already knew from earlier in the problem. But I've been noticing today that if I skip this math, people get like, they feel like I'm just making this answer up. So I showed you the math. Yeah, I plugged in 0. But if you just want to think ahead a step or two, since I already found 0, 0 at this step, I already knew it was going to be 0, 0 for the y-intercept as well. Just depends on what you want to do. All right, so here we go. Now we can start shading in or sketching out the graph. I like to work from left to right, just so I know I'm getting everything like sort of in a systematic way. And again, there's not a great way to start every single problem, but there are some patterns. Here's how I would start this problem. I know that this red line represents my end behavior. So I know that way far out to the left of the graph, to negative infinity, the graph is going to have to be going either like this or like that. Okay, it's either approaching from the top or the bottom. But since I have this point right here, because I won't always have a point on that left side, but in this instance I do. Since I know I have this point, I can infer or deduce, I'm not sure if we're inferring or deducing, that it has to be approaching the horizontal asymptote from below in order to be passing through that point. So I can fill in that piece. And then as I go along to the right, x is going to be, as x is approaching this asymptote, the graph has got to get closer and closer and closer to it without ever reaching it, and that's just going to look like this. Okay. So I have that left part filled in. So still moving from left to right, now I have to fill in the middle part. Since I've just crossed this asymptote right here, I have to go to the t section. Okay. What information do we have from, is it together at the asymptote? We wrote no, it's got to go opposite. Okay, this is only determining the behavior on either side, not past it, but just what is it doing on either side immediately as it comes across the asymptote. So if it's down on the left side and I got to go opposite on the other, which way is opposite from down? Up, right? So just immediately on that side, I know that it's got to be going up that way. So I'm just going to put an arrow there for a placeholder while I think through the rest of that middle section. So now I know that I have another piece of information there. I have that 0, 0 point. The graph has to go through there eventually. And I've got two choices. It's either going to go through there and bounce up, or it's going to cross. Which one did we already determine it's going to do? Cross. And so as x goes to the right, the graph is going to slowly be going that way and approaching this next asymptote and going through the point. And so that's why that next section looks like that. Yes, sir. By which one? What do you mean? You mean like this left section? I am doing that as just trying to be consistent, but there are cases where you might not have to start there. Is that an awful answer? It is kind of awful, right? I really want to say, yes, always start on the left. That's not a bad answer either. Let me go back. Yes, always start on the left. Yeah. Okay. And so then we've got that middle section filled out. Then we have to go to the last section right here. So moving from left to right, if I'm going down on this side of the asymptote and all my asymptote behavior is opposite, if it's down here, what is it on the right-hand side? Up, right? Opposite. And as it goes out to positive infinity, there's no more asymptotes to consider. So as it goes out to positive infinity, it has to be approaching this horizontal asymptote there. And so then I can just put a smooth curve between those two arrows. All right? I mean, kind of all right. Okay. What we're going to do now is some actual problems. We did not get through the first problem in yesterday's homework, did we? Did we try it or start it at all? Okay, so let's look at that now. Bless you. So we're going to kind of just do this back and forth and work through this problem. For S, for simplifying, we have to factor the top and bottom. How does that work in this problem? You don't need to do it, right? Those cannot be factored. X plus 3 just stays like it is. X minus 1 just stays like it is. So that's not applicable. What about H? No H's. Because H is for anything that cancels, nothing canceled. What does R represent? Roots. What am I going to set equal to 0 for that? X plus 3, the top. Bless you. So top equals 0. That means X plus 3 equals 0. And I get X equals negative 3. What form do I write that in? A point or a line? Point. And we graph it. So if that step was letting the top equal 0, what's the next step? Let the bottom equal 0. This is your vertical asymptote, so my bottom is X. Oh, there, on the graph. Okay, thank you. I was staring at this negative 3 so hard, I was like, it is negative. I don't know what you're talking about. Okay, thank you. So X minus 1 equals 0. X equals 1. Is this supposed to be a point or a line? Line, right? So I'm going to leave it like that. X equals 1, because it's an asymptote. And then for our T information, we're looking for anything, any factors that are squared in the top or bottom. Do you see anything, factors that are squared? No? All right, so here's what we got. If the tangent is no, that means it will cross at the root. And if the together is no, that means it'll be opposite at the asymptote. And remember, that's just information we're just going to hold there for a bit. We're going to actually use it later. E is for M behavior. You're looking at the original function. Of course, we didn't factor anything here, so it doesn't matter. But you're looking at the leading terms. It's the terms out front, the very first term on the top and bottom, which in this case is x over x. How does that simplify? 1. And so our horizontal asymptote is at y equals 1. And the last thing is y. That stands for y-intercept. What am I going to let equal to 0 there? What does that mean, what 0? The x is 0 for the y-intercept, yeah. Yes. So we're going to plug it in to find the y value. So I go back to the original equation. I do 0 plus 3 over 0 minus 1. Is it a minus 1 or a plus 1? Thank you. And then 3 over negative 1 is negative 3. So this is a point. X is 0, y is negative 3. So we're going to start on the left-hand side. And I submit to you for your consideration that there's not even any fancy thinking that we have to do here. Because we have 2 points on the left-hand side. That's already a lot of information. We just have to connect them. But how are the arrows going to go? So, I mean, I can connect them, that's fine. This is going to go down like that. And this one is going to approach the horizontal asymptote as it goes out to negative infinity. On the right-hand side, we don't have any points or anything. But there is some other information we have that can help us determine the behavior on the other side of the asymptote. Which letter am I going to use? T. I know that at the asymptote, it's going to go in opposite directions on either side. So here's my only asymptote. It's going down on the left. What's it going to have to do on the right? Up. So it's going to be approaching the horizontal asymptote from above, like that. Okay? I want you to take a few minutes and work through all the letters for the next problem. You don't necessarily even have to begin graphing it, but at least work through those pieces. Horrible? It's okay? So we got horrible, we got okay. Did anybody do fabulous? No, fabulous? Okay. We start by factoring the top and bottom. Okay, that's our S step. You kind of don't have to factor the top. It's really just x times x. You could, if you want to, though, write it like this. Okay, that is technically factored, x times x. The bottom, x squared minus 4, is a special factor rule. It's difference of two squares. But let's say you forgot that rule. You can still do swing. You would just say, well, it multiplies to negative 4 but adds to 0, because there's no b term. There's no middle. And you would still come up with negative 2 and positive 2. Okay, so now that we have it in factored form, does anything cancel out here? Is there anything that's the same in the top and bottom? No, right? So since nothing's canceling, that H step is not applicable. For the roots, we set the top equal to 0. If you were going to keep it in factored form, you could do this one of two ways. Here's way one. You could just say negative 2x squared equals 0, which I saw some of you do. You divide by negative 2. You get x squared equals 0. You square root both sides. And you get x equals 0. And that would give you the point 0, 0. If you let the factors equal 0, the negative 2 part you don't have to worry about, but you would let x equals 0 and x equals 0, so this is the second way. You let the factors both equal 0, you're still getting what? 0. So you still have 0, 0. One thing I do want to point out, though, is that this is a double root. So when we go to graph what kind of behavior is going to happen at this root, it's going to bounce. Okay, it's a double root, which you can see right here because that x is squared. Okay, that's a squared factor. Bless you. Now, in the denominator, this x squared is not a squared factor, okay, because it's got that minus 4 attached to it. So when we go to figure out the bottom behavior, we're looking at the factored form here, x minus 2, x plus 2, not that x squared in the bottom. So to find the asymptote, so the root is let the top equal 0, the a is let the bottom equal to 0. We have these two factors. We're doing factored form for that step. So that's my two factors, setting them equal to 0. Then I solve them. And these are lines, so I leave them in that form. So there are now 3 sections of the graph that I'm going to have to figure out. The next thing I'm going to do is the t information. Is it tangent or together at the roots and the asymptotes? In the numerator, I have a double root. So that's a yes, that's going to bounce. In the bottom, we're looking at factored form. My factors are x minus 2 and x plus 2. Neither of those are repeating. Neither of those is squared. So that's a no. So at both of those asymptotes, it's going to be opposite. E is for end behavior. That's my horizontal asymptote. I need the leading terms, but that's the original equation, okay, not your factored form. So my leading terms are these. I write them as a ratio and simplify. I'm going to get negative 2. So y equals negative 2. And then for the y-intercept, I'm plugging in x equals 0 to the equation. You can do factored form or the original. I'm going to do the original. This is 0. So my y-intercept is 0, 0, which I already knew because it's the same as from the other point. All right, so here's where we start graphing. And I had said earlier, I said, you know what, let's just kind of make it a rule that we start on the left-hand side. What kind of information do I have on the left-hand side? None. I don't have any points there. You know how I could get a point, though? I just do a test point. At any time, the whole process where you're graphing, if you feel like you need additional information, you just do a test point. Okay, that's not even, and that's just something we should feel comfortable doing no matter what, under any circumstance. If you need a point, you get one. If I need a point that's to the left over here somewhere, and I need something to the left of -2, I'm just going to pick a good x value that I think would work. I like -4. Okay, so here's -4. So I'm going to do a test point at x equals -4. So I just take -4 and I plug it in to the original equation. That gives me -2 times -4 squared over -4 squared minus 4. The only tricky thing about this particular problem is you need to follow your order of operations and be careful for all of those negative signs. Because while test points are completely valid things to do, if your math is bad, you're going to confuse yourself more. You're going to confuse yourself unnecessarily because you're going to be trying to fit stuff together that doesn't because your math was bad. So following your order of operations, exponents first gives me -2 times 16 up here. 16 minus 4 on the bottom. That's -32 over 12. This is approximately -2.6. Okay? And that was when I let x equal -4. So at -4, y is approximately -2.6. Okay, so I have generated a point to help me get started graphing. So I'm going to put that in my graph. -4 and -2.6. And this was the information I needed to get that left side graphed. Once I get that left side graphed, everything else is just like filling in the pieces of the puzzle. Okay. Now, as we go over to that middle section, my question for you is, what's the behavior at the asymptote? Opposite, right? So if it's down on the left-hand side of this asymptote, what is it going to be on the right-hand side? Up. And one thing I want to say is that when you're asking yourself, is it opposite or together, it doesn't mean for the whole length of the graph. It means only in those tiny sections of time. Like on either side of this particular asymptote is a completely different situation than you have to completely on this side of the asymptote. I didn't say that very well. I'm going to re-say that again in just a second. Just scratch everything I said for the last 10 seconds. I'll repeat it in a moment. So this is down, this is up. I have to figure out how to fill out that middle section. What do I know about the behavior at this root? It bounces. All right. So when I know it's going to be coming down like this, and then it's going to bounce and go right back up. Okay, because that's what bouncing does. So now I'm at the next asymptote. It's also opposite on either side. So it's up on the left. The behavior immediately on the right is going to be opposite, which is down. Excuse me. And so then I can just fill in this bottom right-hand side because I know it's going to approach that horizontal asymptote as it goes out to infinity, like this. And that thing I said so awfully a moment ago, here's what I was trying to say. When the asymptote information is that it has to go in opposite directions, you might be noticing when you're looking at this graph that these things are the same. Do you see that? Okay. So when we're talking about opposite at the asymptote, we really just mean in this isolated section and in this isolated section. What's happening immediately on the left and immediately on the right here, which is a whole different thing than, and you got to redecide that over here. It's not like flowing through. Yes, sir. It's opposite behavior, yeah, as it's going up and down on those sides. Any other questions about this problem? Okay, so please remember, we're not going to get to the last problem. I do want you to do that last problem for homework. I'll put the key on Google Classroom this evening. Remember, I cut off 61 and 65. So it's really just 57 that I want you to try tonight, okay? And the key will be online.